Okay, so the next one is a hypothesis test. It says in a study, police gunfire reports during a recent year, it was found that among 230 shots fired by New York City police, 147 hit their targets, and among 270 shots fired by LA police, 160 hit their targets. We want a zero point 0.5 significance level to test the claim that New York City police and Los Angeles police have the same proportion of hits. So this is a two proportion. Um, this is a two proportion test. Two prop z test. So if we want our H naught, we want P1 to be equal to P2. And we're going to test the claim that they have the same proportion. So it's either that or they don't have the same proportion. P1 is not equal to P2. Obviously, you have to read that last part to figure out what the proposition or what the claims are. So critical value, we don't use that, so that will not be on the test. P-value will be. So we're going to use our calculator. We're going to go to this is a test. So we go stat, tests, 2 prop z test. 2 props because there's 2 different ones. But we've got our x1, which is the number of hits. 147 out of 230. Remember, n is always the total number for a proportion. In the other problem, we did not have the total written down for us, so we did not have to copy that down. But in this one, we do have it written down. 270 shot, 160. So let's do that. We have 270 shots, 160. Not equal. Oops. Okay. Oh man, what is going on here? It doesn't like me this morning. There we go. So our p-value is this number, 0.2867. So for that one, we'll say 0.2867. This is two-tailed. Test by constructing a confidence interval. This will be on there. So if we wanted to do this one, we're going to go back to the same menu, but this time instead we're going to go to we're going to go to 2 prop z int. Okay, and since the significance level is 0.05, that means the confidence level is 0.95. Those are basically complements of each other of the statement. All of the information will already be there. I'm going to write that down. So in this case, we have negative 0.0388. And then we have 0.1319. Okay. And based on our calculations, should we fail to reject or reject it? So since 0 is contained in this confidence interval, the number 0, 0%. 0% would indicate that there is 0% change in these, or 0% proportion difference in these two things. So we should fail to reject the null and the proportion is about the same. And so obviously we're saying it's about the same because we tested if they're different. So that's the alternative. And so I guess to answer the question, to answer the real question, it says, do they have the same? Yeah, they do have the same one, and that's found on H naught in this case. Since H1, the alternative is that they're not equal. Okay. For the next one, we're going to do the calculator, so we're going to have to enter all these values. So let's see what I can do. Stat edit. I want those conveniently located. So here we go. Clear both of these. 65, 404, 1567, so these are enrollment numbers, and then numbers of burglaries, I guess, in thousands. No, not in the thousands. The enrollment's in thousands. The burglaries is just that number that's given there. 252. Otherwise, there'd be a lot of burglaries for these places. 111. Oops. And I hope that's all of them. 2, 3, 5, 6, 7, 8, 9, 10. Uh-oh. 32. All right, let me go through. 32, 146, 32, 154, 111, 252. Oh, it's one of these ones. Okay, there we go. It's better. 30, 44, 92, 56, 46, 61, 25, 26, 18, 16. Okay, so we've got that entered, so now we can look at a linear regression equation. Since it wants ax plus b, that's this button. Obviously, if you look lower, there's a plus bx. Those basically do the same thing, it just gives them in a different order. List 1, list 2. Oops. This is obviously under calc. We calculate it, we get 0.39. .3909 or 0.3910 x plus b, which is 25.21. .2135. So there's the equation. I think this is just one question, but then it says find the best predicted for the number of burglaries for an Ohio State student, which had 35,000 students. So remember, these numbers up here are thousands. So this is 32,000. So then 35. So you'd plug 35 into this. So let's do that. We have 0.3910 times 35 plus 25.2135. And we get 38.89. We're going to round to the nearest whole number, which in this case would be 39. And so there would be 39 burglaries for, well, we'd predict that there's about 39 burglaries. That's the best fitting line that predicted it. So there's about 39 burglaries for 35,000 people. So thank you guys for watching. We'll get into the last one here in a sec.